Right, somewhere else you might like to use hypothesis testing, looking at performance of your employees. In this particular case, we have an S1 module at a particular school with a pass rate historically of 0.8, i.e. 80% of your students passing every year. A new teacher is appointed, congratulations, and takes the next group of S1 students. Out of the 10 in this group, only 6 pass. That's lower than the historic average. Should our head of maths be concerned about this performance? Great question. Let's find out. Okay. So our hypotheses, let's just bear in mind 80% pass rate. So the hypothesis, null hypothesis, would be that the results are in line with historic pass rate, i.e. that the probability of passing is still at 0.8. The concern would be that we've dropped below this now. So our alternate would be that the probability of passing has dropped below the 0.8 and it's time to get concerned. Maybe we can give the teacher support for more training or help with their classes. So we'll start with saying the null hypothesis is a probability of 0.8. Things haven't changed. Where P is a probability that a student passes. So again, I'm defining what my P stands for. And the null hypothesis would be if that's less than 0.8. Next step, decide on significance level. Again, we are going to use the magic 5%. Okay, now let's think what we are looking for. So we're saying here that 10 students took part. So I'll run myself with this. 0.8 pass rate. Only 6 pass. So is it unusual that 6 or less would pass under normal circumstances? So what we're looking for is probability that x is less than or equal to 6. Now from this point, or before this point, you're more than welcome to maybe just give it a little go and some thought, pause it between steps if you can like predict my next move. That's your time to pause. The next move is, well, in my tables, I unfortunately don't have a 0.8 column. In fact, it stops at 0.5. Well, I do have a 0.2. So remembering back to our work on binomial, we can look at the case of y. So if x, let's go back here again. So if x was that a student would pass, then y would be the number of students who fail. We are assuming to try to figure out what's the chance that under normal circumstances that 6 or less would pass. So let's think about this. So 6, 7, 8, 9, 10, 5, 4, 3, etc. So 6 or fewer. But then we said we need to change this to the number of students who fail. So this lot here. So if 10 pass, 0 fail, 9 pass, 1 fails, 8 pass, 2, 3, 4, 5, 6, 7. So chance of 6 or less passing is the same as 4 or more failing. Again, remembering in our tables, we need to have a less than or equals to sign. So 4 or more failing is the same as 1 less than 3 or less failing. And from your tables, you'll find that to be, that should be a Y there, my apologies, that's terrible. It should be Ys. That should be 0.8791, which is 0.1209, or under normal circumstances, there's a 12.09% chance that 3 or less would fail. Let's put that back in the original, which means under normal circumstances, assuming that this pass rate hasn't changed at all, that this teachers may be just unlucky for the tests, as other students, that the chance that 6 or less would pass normally is 12.09%. Now given, and again, I know it's not a normal distribution, but just to describe it, given we're talking about a 5% pass rate, so a 5% chance of this happening, we're saying we'd be suspicious if the chance of getting 6 or fewer to pass was less than 5%, we worried that this teacher was a bit unusual, a bit weird, a bit not quite matching, needed extra support and help. But because we're saying actually the chance of that happening normally is 12.09, so if you had the old teachers back, there'd still be a 12%-ish chance that only 6 or fewer would pass. We could actually say, actually, this teacher isn't particularly out of step with the historic average. So what we can say is that there is insufficient evidence to reject the null hypothesis, which is that students are underperforming with this teacher based on this one sample. Don't know if that's even legible. So again, we're not actually saying definitely that this teacher is underperforming. We're just saying with this one sample, there's insufficient evidence to reject the idea that she is underperforming.